All right, we're going to look at number 5 now. And just as a note, for those of you who are actually watching these videos before Easter or during the Easter break, the Easter weekend, good for you, because on Monday, while we're splitting up, guess what problems we're doing? We're doing this page of problems. So if you watched my videos already, you worked through them, and you paid attention in class, you're going to have a leg up on the competition. All right, that said, let's take a look at number 5. While completing a practice test online, Malaya, it's a cool name by the way, answered 6 out of 20 questions incorrectly. If the ratio of incorrect to total questions remains constant, how many questions should Malaya answer correctly out of 30 questions? Wow. Okay. You know what? I'm not sure. I feel like I might have done this one wrong. Just because reading it right now, I'm paying really good attention here. But we'll see. We'll see what. I'll make a note of what I'm thinking right when we get to it. Okay. So, but what I know that she missed 6 out of 20 questions. Right. And I want to find out. Let's see. I'm going to write that down. She missed 6 out of 20. This is why it's so good to write this down. See, read it over again and find out what you know. I also know that that's all I know actually. And see how many questions I'm trying to find should she answer correctly. How many right out of 30? Okay, so these are different numbers, right? One's talking about what you missed, the other one wants to know how many you get right. So that's why I'm thinking I probably messed it up during class. And I'll tell you right now, okay, I'm going to do the problem in just a second, though. But here's what I'm thinking right now as part of my strategy. Okay, part of my strategy, I'm going to use a strategy called it's called thinking logically and eliminating wrong answer choices. So this is what I'm thinking right now. I'm thinking somebody's going to misread this question. Like Mr. Baker during class. I don't know if I did or not, but someone's going to read this wrong, and they're going to answer the wrong question. They're going to answer how many she got wrong during class, right? She misses fewer than she misses. I mean, she misses fewer than she makes, right? She's not below 50%, right? So I'm thinking somebody's going to pick a number that's too low. All right, they want us to pick a too low number. So when I'm looking at the answer choices, what I'm thinking, well, my mouse isn't showing up here. Oh, wait, I saw it. There it is. Okay. I'm thinking, hey, look, I could use a pen. I'm thinking that the trap answer here is 9 because that's too low. The real answer is 21. And this is why I'm thinking, because these two numbers add up to get 30. You see that? So I'm thinking this is probably the right answer, and this is probably the trap answer, because there'll probably be somebody going through their test and saying, "Oh, she gets 6 out of 20 right. That'd be 9." And they get the right answer to the wrong question. So I'm thinking this one is probably how many she missed. And look at that, I can actually write on here. And this one is probably how many right. Look at that, without it doing any math. That's just logical reasoning. Now it's going to show up. I'm going to be eating my words here. I'm sorry, that's the right one. I'm going to be eating my words here when I go back and I find out that actually their answer is 8 or something. But let's do the math here, just to make sure. Okay. But that's a strategy. You can be looking at answer choices while you're reading the problem just to see if there's any clues in there. Okay, let's take a look. I'm going to, let's see, what should I do here? I can set up an equation pretty simply. If you know how to write a proportion, that'd be a pretty good one. If you know that, let's see. So if you miss 6 out of 20, either way you have to convert this somehow. If you miss 6 out of 20, it means you're making 14 out of 20, right? There's 20 questions, you missed 6 of them, that means you got 14 right. So here is what she got right on the first test. I want to know how many she got right on the second test. So you could set up a proportion like this. This is probably the best and easiest way of doing this. And that's one of the strategies, right? Write an equation. Let's say, I'm going to go ahead and solve it this way, and then we'll see what else we could have done. Now, before I do this, now to find the missing value, I'm going to cross multiply this times this, and then divide by that one. All right, to get that. But before I do that, I'm going to make the numbers a little bit easier. 14 and 20 are both even. So I'm going to reduce my 14 over 20 to 7 over 10. That'll make it a little bit easier. All right. And now I can cross multiply. 7 times 30 is 21 with a 10 on the end. And then divide by 10. Well, we've been doing that all day long, right? Divide something by 10, you just shift the decimal place over. So that would be 21. So I think my correct answer, by doing my proportion, is 21. Is that the same thing I got? Hey, it is with the logical thinking, 21. All right, cool. There it is. Now, in class, I think what did we do? We did a bar model, I'm thinking, right? I'm not sure how we did that, though. Well, let me try something here. All right, if this doesn't work, well, I'm sorry. You'll just have wasted a little bit more time. I'm going to draw you know what? We'll draw a bar model that is 10 long, just because. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would have drawn 20, but that'd be really long. And 10 is nice because 10 goes into 20 evenly. So each of these squares is actually not 1, it's 2. That's 2, 4, 6, 8, 10, 20, 12, 14, 16, 18, 20. All right. And out of those 20, she got 14 right. So that's 2, 4, 6, 8, 10, 12, 14. Those are the ones she got right. Okay, new test. Let's pretend now this isn't 20. This is now 30. All right, little bait and switch there, okay? So now, if this bar, I didn't change the number of squares on it, I just made it 30 now. If this bar is now 30 questions, how many questions is each little square? Let's see, I got to divide that 30 by 10, right? Because there's 10 squares. So now each of those squares isn't worth 2 anymore. Now it's worth 3. And now I can do the same thing now. So if I have 3 and 7 of them are filled, 3 times 7 would give you 21. Or I can count by 3. 3, 6, 9, 12, 15, 18, 21. 21. All right, we keep getting that number over and over again. I'm pretty sure 3 different strategies. That was that for checking your work. My last step, E. Hey, we checked our work like nothing else, man. That is definitely 21. All right, until next problem. That's the last one.